Thank you, thank you. Thank you for staying. Just so you know, it's very bright up here, so if you do want to leave, I won't even see it happen. So it's fine, you're fine. All right, so if not, if you do want to stay here, I hope you're ready to get legit. My name is Pauline. I'm a software engineer from Amsterdam. I am also a speaker, clearly. Mostly about Git. I have 2 Git talks. One is more of a foundational Git talk about kind of best practices and my Git ethos / methodology, I suppose. And the other one is kind of a sequel to this with more kind of advanced tricks. But this one is more of a foundational one. So if you want to get into how do I make my life considerably easier when I use Git, then this is the talk for you. That is my handle on Twitter. If you're not into Twitter, my Mastodon handle is also on there. But without further ado, let's get ready to get legit. Because I wonder if all of you recognize this state of being when you use Git. I think we've all been there, but I promise you that when we get through with this, and it will take you some getting used to changing habits, but once you do, you can go from this state to the ideal state that everyone wants when they're programming, when they feel like a hacker and their hands are dancing over the keyboard. That can happen, trust me. You'll just have to get used to it a little bit, but before you know it, it took me about like a week or 2 weeks. Before you know it, it'll be second nature, and you'll really feel like this, even while using Git, I promise you. All right, and the foundation for that is atomic commits. So hands up, I'll try to see in the crowd. Has anyone heard of atomic commits? Few hands. Keep your hand up, actually, if you're using atomic commits. Okay, sweet. Okay, so if you don't know what atomic commits are, you don't need any sort of specific type of tooling for it or anything. It's just a way to organize your commits. So if you look at the word atomic, it's something that's so small that you can't divide it without breaking it, basically. So that's kind of what atomic commits are. They're very, very small commits. And I personally feel that they have 3 sort of main features. And that the first one is that they're a single irreducible unit. So one commit only does one thing. You're only doing the one thing, one fix or one feature or one small refactoring in this one irreducible unit. So you can't break it apart any further. Then second, ideally everything works, which means that the application is stable on every commit. Ideally all the tests are green. Ideally, the tests exist. That'd be great too. And you don't break the build or anything like that. We'll talk a bit more about why that's important later. And number 3 is they're all clear and concise. So the commit messages are very clear and concise, which is a lot easier already when you keep to point 1 of every commit being a single irreducible unit, because it's much easier to say very clearly and concisely, I did this one thing in this one commit. So the purpose needs to be clear from the commit message and the description. All right, so that's basically it. Again, you don't need any sort of special tooling for this. This is just a way of organizing your commits in this way. It's really it. And it might sound simple, but it will help you with a lot of things in your Git life. And the most important one, we'll go through a few of them, but the most important one is probably keeping your sanity. Because, okay, imagine this scenario, which I know a lot of you will probably know. So you've started a task, you've branched off, a teammate of yours has started working on the same task, has made their own branch, and now your teammate has finished their work, they're creating a PR, they've merged it, and now you need to get those changes onto your branch because now you depend on that. So you basically have 2 options. Who would do a git pull and pull the changes in? A few hands. I feel like it's genuinely more more hands than that, but it's always a bit hard when it's a show of hands. It's like, not everyone is extroverted enough to put up their hand. But yeah, so that's a very common choice, to pull changes in and then make a merge commit of those changes, because you're smushing together those changes with the ones that you have. Another option is to rebase. Are there any people who would rebase onto, okay, the base branch? Cool, quite a lot, which is nice, I think, or can be nice rather. But let's have a look at what the basic concept of both is. So when you pull and thus merge, so this is your base branch. So you'll see that there's 5 commits here, and then you've branched off and you've made 3 more commits. So basically when you pull and merge, you're pulling the changes from these 3 commits into your branch. What a merge will do is it will compare the diff of the head of both branches, the head being the last point in time of that branch. It'll check if there's any merge conflicts. If there is, you can resolve them, and if not, it'll just make a merge commit saying, okay, I've consolidated the changes from the 2 heads of this branch and made 1 merge commit as a consolidation, and just smushes them together in 1 merge commit. So it's pretty straightforward. The only thing is, in that merge commit, it's basically kind of impossible to say what changes happened there, because you're going to have changes from kind of all over the place. There's not one thing that it's doing, so you can't really say much more than, you know, this is a merge commit. You can't say, oh, these changes are this and that. And if you keep doing this, you'll keep having these merge commits kind of show up in your history that don't really tell you much. And then with rebase, so we have the same kind of starting scenario. We have a base branch and your own branch, and you have some new commits. So with rebase, instead of consolidating the heads of these 2 branches, it's going to replay the commits chronologically, and it's going to take 1 commit and then see if there's merge conflicts with the next commit. And if there is, then you can solve the merge conflict, then rewrite your own commit so that it no longer conflicts with the one on the origin branch or on the base branch. And then that's how it kind of replays all of the commits and rewrites your commits if it needs to, so that your commit messages can kind of stay the same. But you're changing your original commits to not conflict with the other ones, if that makes sense. So like here, for instance, we'll replay this one and compare it to this one, and it doesn't have any conflict, so we'll just move that over here. And then there's this next one, and then, oh, that one conflicts with this one, so we'll solve these merge conflicts and then make essentially a new commit out of this one to consolidate it. Then the next commit is fine, and so on and so forth until you get to the end. And then you have all the changes onto your branch, but you don't have any merge commits, and you're keeping your history kind of clean and the same as you intended. Okay, so that's kind of the difference. The problem with rebase is a lot of people start using it without using atomic commits, and that's when you end up with this situation. You'll end up with the same conflicts over and over and over again, and you'll be like, why is this happening? This is what happened with me when some years ago, someone came back from a conference and was like, I heard that we're better off doing rebases instead of, but with no further context. So we all started doing it and then realized that, you know, we were losing so much time with this specific problem that it wasn't productive at all, and we just gave up. And it wasn't until years later that I realized why this happened. Okay, so that brings me to the next thing. We'll get back to as to why this happens in a second. But the next thing atomic commits are very good for is history. So when you organize your commits in this way, it's going to be much easier to kind of see what happened in your history. It's going to be much cleaner, but also you can start time traveling very confidently along your history. You can go back in time, and you can be pretty confident that the application will be in a stable state. you can check checkpoints and timeout and start your application and know that it won't break and things like that. And it's just much easier to see what happened, basically. So one thing that people kind of automatically start doing when they start using Git is they start seeing commits as kind of save points, which makes a lot of sense because we're used to that from a lot of software. So like, for instance, in video games, you make a bunch of progress, and then you're like, okay, I need to get to a save point because if I die now, then all my progress is lost, right? So it's like a chronological kind of checkpoint thing. The same with things like Word documents. You type a little bit, and you're like, oh, if my computer crashes now, I'll lose everything. So I need to just type a little bit, save, type a little bit, save. And so that kind of feels natural. So that's how you start using Git. You do a bit of code, you save, commit, you do a bit more, and then you commit again. And then what you end up with is kind of these checkpoint commits that represent kind of time. But the way Git is designed makes it so that's not super ideal. Let me show you what I mean. So this is an example of those checkpoint commits. Just start at the bottom. There's a bug that's been reported, and you set out to fix it. So you fix this bug, you commit it, and then you realize that by fixing the bug, you broke something else, which is classic. So then you're like, okay, I gotta fix that and commit that, and then you go fix the fix, and then you create a PR, and someone rejects it, and then you'll address the comments, and you'll say, addressed comments, because that's really all you can say about it, and so on and so forth, until you kind of end up with this. And there's a few issues with this. Namely, first of all, that in a lot of these commits, the application is captured in an unstable state, so it's going to be broken in more than one of these commits. Another one is that outside of the scope of this PR, people won't know what happened here. Address comments doesn't mean anything outside of the scope of this PR, right? So it's not going to be easy for people to understand what's going on there. When initially what you set out to do was you wanted to fix the small bug. Right? And this is also, this kind of checkpoint behavior is also why you get the same conflicts if you rebase with these checkpoint commits. Because the thing is, if you look at all these commits, there's going to be, you're going to be working in the same part of the code over several commits. Because here you were fixing a small bug, and then here you were addressing comments, so you're probably working in the same exact part of the code, right? So if you start rebasing and it starts replaying, and you have a conflict here, you're going to have the same conflict here, because it's going to replay that one, and then that one, and then that one, so you're going to have to solve the same conflict over and over again. Okay, so how do we ensure that we can organize our commits so that we can really communicate that, hey, this is what happened, this is what we wanted to do? Well, in this case, we can use amend, which looks like this. So here you'll see that we have these two commits here, and I'm going to just make a quick change. So that's in my unstaged changes, and then I can stage it, and then simply git commit -- amend or -- am. And then it'll open a swap file, which is literally just a temporary text file. It'll open in your default text editor, and it will let you edit the commit message. And then if you save and quit that, Git will parse it. So a lot of how Git works is through these temporary text files, these swap files. So it'll parse a file after you save it, and it'll do whatever with that, depending on what you're doing. And so it will do things based on what you've written in that swap file. So in this case, it opened a swap file with the commit message that you were amending, with the commit message of the commit that you were amending. So you can change the commit message, and then when it gets saved, it will parse it, and it'll change the commit message. Okay, so this is how you can add changes to the last commit that you made. So you can just keep going, add it to the last commit, keep going, add it to the last commit. And that's one way you can kind of organize so that everything is, all the changes are in the unit that you intended them to be. But what happens if you know, in the previous example, you had 5 commits, right? And there's someone's requesting changes that are relevant to different commits. So not just one commit, but maybe your last commit and your third commit from the last commit. Amend won't work because with amend, you can only amend the last commit that you were working on. So in that case, you can do an interactive rebase. So we already talked about rebase just now in the context of rebasing onto another branch, but you can also rebase onto your own branch. And you can do it interactively. So what we were just talking about before was Git replays the commits for you and checks if there's conflicts in this and that. And then just goes through it like that. With this interactive flag, so it's either -- interactive or -I for short, you're doing the same, but you get a little bit more control over how you're replaying the commits. And that's what this looks like. So if you add the interactive flag, it'll open another swap file. So again, just a text file opening in your default text editor. And here you'll see the commits that it's going to replay in your rebase. And you'll see that it's prefixed with the word pick there. And here you'll see a little legend. You'll probably, if you try this, you'll see a bit more, because this is an older version of Git, and since then there's been more commands that have been added. But you can replace that pick with anything from this list, and then tell Git how to replay it in that sense. So pick is the default behavior, so you just replay and do nothing with it, essentially, unless there's a conflict. Then R for reword is just gonna open that swap file with the commit message, so you can change the commit message if you want. Edit gives you a lot of control because it basically checks out the entire commit as if it was your head, basically. And then you can add more changes, reword it, anything you like. Then squash and fix up are kind of similar, because what that does is it takes the commit that you're prefixing it with and smushes it into the previous one, so it makes one commit. The only difference is that with fix up, it'll just automatically take the first commit's commit message, and with squash, it'll open a swap file with both of the messages, and you can either choose one of the messages or you can create a new one for this joint new commit. Then exec is an interesting one, because you can add a script to this commit that it will run. So for instance, if you want to ensure that certain commits pass linting or something like that, or you want to run tests over a certain commit, you can use that one. And then drop is kind of there for, I guess, for to be more expressive, because you don't actually need drop. You can simply remove a line to drop a commit. But what it does is it removes the entire commit and all the changes that were made in it. That's what an interactive rebase looks like. And again, you can do that onto your own branch as well, like this. So instead of saying git rebase -I other branch, you go git rebase -I head, which is the current moment of your current branch, ~4, meaning I want to go from my head until 4 commits ago, basically. So this is what that will look like if you do the whole thing. So you'll see I have some unstaged changes here. I'm going to stash those for later, and I'm going to enter my interactive rebase. I'm going to go back 5 commits, and here I'm going to say I want to edit this one and this one. So it's going to start replaying, and it will stop at the first one I wanted to edit. Then I'm going to get my stash back and stage that. And when I git rebase -- continue, it will treat it as though I've run git commit amend. So it will amend that commit with these new changes that I staged, and I can change the commit message. Then it will replay the rest and stop again at the next one that I wanted to edit. And I can make some new changes, stage it, add it in the same way, and then git rebase -- continue. And then that was the last one that I wanted to edit, so it's done replaying, and you're back at your head. And now you've essentially rewritten history. One small side note is that because you're rewriting history, The way Git identifies commits is by commit hashes, which are generated from the delta, the diff. So the changes that they introduce. So now, because you are adding different changes to a commit, the commit hash is going to change as well because the delta has changed. Now your origin, if you've already pushed to your origin is going to think, hey, this commit doesn't match with what I have here. So if you attempt to push it and it was already there, it's going to say this didn't belong here, and it will reject your push. So what's the solution to that? You have to force push if you start doing this. And some people might think that's very scary, but I'm here to reassure you that everything's okay. But we'll get back to that. But don't worry, this is normal, expected behavior for you to, if you start doing atomic commits, it is totally fine and normal to force push. But there's some conditions, but we'll get back to that. Okay, so another thing atomic commits are going to help you with is code reviews. So when I started working with Git and GitHub for me personally at the time, I would go to a PR and I would go to the files changed because you want to see what files changed. So that's where you go. But the problem with that is, like in this case, there's 30 files that were changed in no particular order with no context other than the PR description. So it's a lot to review in no logical chunks or anything like that. So I don't know if you have any focus problems. I do. But if I start reviewing something like that with no clear structure, I get scrambled brain and I have to start over again 5 times because I don't know what I'm doing. So it's going to take me a lot longer to review. It's not going to necessarily improve the way I review or the quality of my review. So it's not a fun time for anyone. Now with atomic commits, instead of looking at the files changed tab, I can start reviewing commit by commit. So I can open the commit tab, and what I tend to do is these days you have like navigation shortcuts, keyboard shortcuts as well, I think, in most things. GitHub definitely, GitLab I think as well. But yeah, what I tend to do is I just open each commit in a new tab and just go tab by tab, basically. And what's so nice about this is because you've given everything a very clear message, you can just get the context from the message of this one small logical chunk that you're reviewing and then move on to the next. And the reason you can't do that if you're not, well, you're free to try, but the reason it doesn't really make sense to do it that way if you're not using atomic commits, if you're using these checkpoint commits where you're committing in a time linear fashion, is if you're reviewing something and you're at the first commit and you're like, oh, this doesn't make sense, I'm going to request some changes, and then it turns out that they actually already fixed it in the 5th commit. That's not a super efficient way of reviewing, right? And with atomic commits, you're not going to have that because everything that pertains to a single commit is going to be a part of that commit because it's been amended, if that makes sense. So that's another very nice thing that you can then kind of have a much more structural, brain-friendly way of reviewing. And a little bit about commit messages. You'll see here that I have this nice little short block of context, which is very helpful in reviewing. But there's, of course, many different ways to write commit messages. There's, a lot of people will prefix a commit message with feat or a fix, like for a feature or a fix, or some people will add the task number for their task manager, for instance. There's also Gitmoji. I don't know if you've ever seen that. That's pretty popular in a few like open source kind of environments where they prefix everything with a little emoji meaning something. So like a little cogwheel will be like, oh, there's some configuration changes. It's kind of fun. You'll get a very nice, colorful history. But I think the most important thing is to have kind of a team consistency. So to have sort of an understanding of what your commit messages look like. And I do find that there are a few rules that are really handy to at least apply. So that's from this blog post, which should still be here, which is quite nice. If you want to have a look at it, there's some handy stuff in there that I'm not covering. But these rules are from there. So one of them is to separate a subject from the body with a blank line. And that is, we'll see in a bit why that's a very good one to keep. Then limit the subject line to 50 characters. The 50 characters is a little bit arbitrary, but at least like limit it to some point, not only to force it to be a little bit concise, but also because of the nature of reading something in a terminal that things might get cut off. You'll see that in a second as well. Ooh, a bit too far, sorry. Capitalize the subject line. I find it a little bit easier to read if you do apply this, but it's a little less important, I think, probably, as is this one. This one is also a little bit more arbitrary. It saves you a character. But I think that one is, but this one, I think, is a lot more efficient than you might think at first glance. So use the imperative mood in the subject line. So instead of going fixed, created, or fixes, or you say create, add, fix, and it just reads a lot more directly. So it's more friendly to the brain if you're going through these lines, and you can read it in that fashion. It's just easier to parse somehow. Wrap the body at 72 characters. Again, the 72 seems arbitrary. It actually has historical reasons because the terminal window used to have 72 columns. Now it doesn't really matter if it's 72 or 75, but it is good practice to wrap it like that. So, because before you saw the commit message, that it was kind of a little box shape. A lot of views that you're going to have the commit message in, if you don't wrap it, it's just going to go on and on and on and on and on and on, and you might have to like horizontally scroll, and it's really hard to read. So it's quite nice to just have like a very limited space to read where you wrap it. And this one, I think, is the most important one, IMO, which is, I have to always kind of explain it because I don't think it's super clear from what it says. So it says use the body to explain the what and the why versus the how. What that means is the what and the why is important, and the how, the technical how, isn't super important. You don't have to, for instance, say like, oh, I added a method here that decorate, blah, blah, blah. Like that doesn't really matter that much because that's reflected in the change itself. But what someone that's looking at the history is interested in is what changed and what are the justifications of these changes. Why did you change it? So that's really important in review, as well as like if you run into like some unexpected behavior, for instance, and someone has a look at it and they can see why this was changed, that can be really helpful. So what I always do is the what is the subject line, and then the justification is in the rest of the message in the description. All right, so you might think I don't feel like manually counting 50 characters for a subject line and 72 characters for wrapping my lines, and that is totally fair. So here is, this is specifically for a combination of Bash and Vim, but here is some configuration by my good friend Luis Cabucci that will help you automatically wrap the lines. And it also has some other stuff that I've taken out of it, like spell check and things like that. But there is some really handy configuration in there. Also, if you use something like Oh My Zush, which I also do, I never know how to pronounce that. I feel like it's one of those things that a million different people pronounce in different ways. But Oh My Zush also has this sort of stuff already in there. So that's very nice. So this will end up in these sorts of views. So you have git log, which will show you the entire commit message. And then you have git log -- one line, which is one that, I'm not sure if that dash in the middle is supposed to be there. I always forget if it's supposed to be there or not. Anyway, try it, and one of them will work and one of them won't. But I use this one a lot to get a really quick overview of where I'm at, especially in organizing my commits, as just like very quick identifiers of like, oh, this is what happened there. And this is also, now you can kind of see why it's important to limit that subject line by a set of characters, or a set number of characters, and why it's important to have that blank line in between. Because if you don't, this view might have part of the description in it, and it doesn't really read as well. So here you have like this really succinct kind of subject line, and here if you want more context, there will be like a very clear distinction between, oh, this is what happened and this is why I introduced these changes. So some other quick wins. It's now really quick wins in terms of atomic commits. It's when you're using atomic commits, it now becomes easier to, for instance, cherry pick, because everything is packed into logical compact units. It becomes much easier to cherry pick a commit from somewhere without having to worry about what other changes they're tied into and what other dependencies these changes have. And if you don't know what cherry picking is, it is being able to go to a different branch and pick a commit and drop it into your own branch, which can be really nice if you're working in parallel with someone and you're kind of dependent on some of the things that they're doing, but not their entire branch, so you don't have to rebase onto their branch, but you can just simply cherry pick this commit for a little bit and use it. So this is what that looks like. Yep. So let's say I want this commit. I can go back to my own branch, and I'll see that there's 2 commits there. And then I can git cherry-pick and paste the commit hash in this case. You can also use the shorter ID as well. And then it's on your branch. Simple as that. So that now becomes much easier, and you're much less likely to have conflicts when you cherry pick, and if you do it, usually is much easier to deal with. So that's quite nice. Oh, that's a lost slide that wasn't supposed to be there. Okay, another thing that becomes very easy is dropping stuff. So dropping stuff is something that you think you won't need to do a lot, but once you start doing these atomic commits, you realize that it's actually super handy. And specifically, in my case, I always use this example because it was super handy at the time when typing was introduced in PHP. So like argument types and return types and things like that. We started like implementing this rule that anytime you touch a file, in our code base, while you're there, you introduce typing as well. So what I would do is I would go to this file to do whatever I need to do, put that in a separate commit, and then also add the typing and put that in a separate commit as well. And then what would often happen is that because there was no typing before, then you run your integration tests and things like that, and it turned out that you were passing the wrong types in certain places, so it would break stuff. And instead of then going down this rabbit hole and having to fix it and everything, I would sometimes decide, okay, this is a problem for later. I'm just going to remove this typing for now and just do the changes I was set out to do. And the thing is, if I would have put that all in the same commit, I would have had to manually go back and change everything back. Whereas if you keep it organized in a separate commit, you can simply remove that commit and then you're done. It's 2 seconds as opposed to like, well, depending how many things you added, but it could be many minutes. So it was a huge time saver. And this is what that looks like. So we're going to go into our, let's say I want to drop this. We're going to go into our interactive rebase, and we already saw that drop command before in the legend, right? But you don't have to use that. You can just cut the line. So in Vim, it's dd, and you cut the line, and then it's also gone. So you cut the line, then you save the file, quit, and then the commit is dropped. Super easy. Now the next thing that I want to talk about is a fun one, and it's called bisect. And I usually use an egg or a bunch of eggs and a building to explain what that is. How many of you have heard of bisect? How many of you, keep your hand up if you've used bisect. Yeah, so I always like talking about this one because a fair few people know about bisect, but it's kind of a mythical beast that people kind of have heard about it being very fun and cool, and I can confirm it's very fun and cool. I love bisect, but it's one that seems a little bit, if you don't understand what's happening, but it's actually not that complicated. So to illustrate this, let's take this bunch of eggs and this building, and let's say someone tells you, hey, I want to know which floor on this building is the first one that I can drop an egg from and it won't break. So let's say these are magical sturdy eggs that won't drop on the ground floor. We're going to take one egg, we're going to try it on the ground floor first. Okay, it doesn't break. Then we're going to take the second one, go to the second, take the first flight of stairs, drop it, doesn't break, and then you keep going up one by one, story by story, until eventually it breaks. But let's say this building has like 50 floors, and these eggs are very sturdy. It might take 50 iterations for you to get to the point where you know it's going to be the first floor that breaks the egg. Another strategy, which is more efficient, is to start in the middle. Because if you start in the middle and it breaks, you already know that the first floor that it's going to break on is between there and the ground floor. So then you go into the middle of that, you see it doesn't break there, so you know that the first place it will break will be between there and there. And then you keep going until eventually you're out of iterations. And that statistically will take many less iterations than doing it one by one. And so that's also why it's called bisect. Bisect stands for cut something in half. You also might know this strategy is binary search if you're a CS person, which I'm not, but you might know by that term. It's a similar strategy. So instead of using this for eggs that are magically unbreakable, you can do this in your code base as well. So if you want to find a point in time, so you could either go commit by commit, you could check out a commit and then check out the next commit and see what happens, or you could take a point in time and do this strategy where you take the middle one and then do it like that. So let's say you have this scenario where you have a website and there's a button that used to be in the middle, and suddenly a month later you look and the button is now here. There's no tests covering it or anything, so you don't know when this happened. You can use bisect to find the point in time, the culprit basically that moved the button. Okay, so let's say we already know that a month ago and which commit is the button was still here in the correct place. You can start your bisect by saying git bisect start. You can give it a good commit, either by ID or by hash. Git bisect good and then ID, and then git bisect bad will by default will take your head. So your current point is time. Then it will, I'm going to do it again because I feel like this is always a bit too fast. So we're starting our bisect, right? We're marking a good point in time and a bad point in time, and it will check out the commit in the middle. Then you can check it when it checks it out. So you refresh the page, let's say, and then the button is in the right place. You'll say, okay, git bisect good. And then it will keep checking out commits in the middle, and you'll keep marking them as bad or good. And then eventually, here you'll see 0 revisions left to test after this, and then when it's done, it will spit out the first bad commit, and to get out of the bisect, you go git bisect reset. And so you've really quickly, instead of having to trawl through all these different commits and then try to kind of make out what happened from the commit message, you can really quickly find the culprit in this case. And the reason you can do this much more easily with atomic commits now is because anytime you check something out, it's more likely to be stable. So it's more likely that you can actually refresh the page and it works, and you can ascertain that, like, okay, this is all okay except for this button. This is the wrong part. This becomes especially important if you want to run bisect automatically, which you can also do. If you are interested in that, there is an advanced Git talk that I do that is also online. There's a tutorial where you can try it out. That is super fun. I'm not trying to be dorky here, but that's why I love bisect. When you run it automatically and you let it find bugs for you is really, really great. Okay, so that's the last good thing about atomic commits that I'll share with you. But before we go to questions, I want to kind of preemptively take some concerns away. So you might say, But how do I call people out on mistakes? Because you're rewriting history, right? So you can't like look at a PR and go, oh, you broke the bug fix here, and then you fix it again later. You got to kind of consider what the purpose of source control is. Is it to really be able to kind of point fingers, or is the main idea to capture your application in a certain state and to be able to see what happened over time? So yeah, I think the pros of using atomic commits far outweigh the ability to kind of be able to see exactly what happened when in the scope of like a PR, for instance. Then, how will this affect my workflow? Because you might think that, okay, all of this reorganizing is nice, but it does take longer than simply typing something, committing, typing something, committing. And yes, it does take a little longer at first. After a while, it becomes so second nature that it really makes everything easier, and it actually becomes a time saver. But I do acknowledge that sometimes, especially on a Friday, you might want to just be able to commit a messy commit and push it, and not worry about getting sick on Monday, and then nobody can continue onto your branch, for instance. But you don't want to take the time to organize everything then and there. So I do this a lot, actually. I often make like one big checkpoint commit, and then I reorganize it later. And there's a few different kind of strategies that are all quite similar, but this is the way that I do it. So I have a massive checkpoint commit for a day's work. And then what I will do is I do a soft reset of that. So that will undo the commit, but it will still keep the changes in that commit in your unstaged changes. And then I can start organizing them bit by bit into. So I come back to work on Monday and I do this. So I'll reset it, and then I'll see here, oh, there's, let's see what the last commit was. That's built some handler. So we could already know that this handler file belongs to this commit. I'm going to amend that commit, and then I'm left with some more changes, bug fix, and 2 files that are relevant to feature X somehow. Of course, in real life, you will have your own context of what you were doing, so you won't need to look at it that way. But then I'm going to go add these 2 feature X things. I'm going to make a temporary commit just for my own reference. Just call it feature X. And then the other one, I'm going to do the same thing. So I'm going to add this bug fix thing, and I'm going to create a temporary commit for that, just for my own reference. And then I can interactively rebase. And then by cutting and pasting the lines, I can move the commits up or down. So I'm going to take this feature X and put it next to the commit that it was supposed to go in. And the same for this bug fix thing. And then I'm going to change pick to F for fix up. And then it will take the temporary commit and just throw it into the original commit, and then it's where it was supposed to be. So that's how you kind of organize and rewrite history, and even after you've already made this checkpoint commit. So you can just go back and organize it after the fact. Then the last thing, isn't force pushing scary? Yes, it can be. For one, I think it's always important to have your main branch protected against pushing and force pushing. I think your main branch there's no reason to push to your main branch. If there is, there's probably something that you might want to look at with your branching workflow. So always protect your main branch against force pushing. And what I like to do is I always work on my own branch. I never share a branch with anyone. That's just, I enjoy working that way. There's no reason for me to share with anyone, because they can have their own branch and rebase onto my branch if they need to, and vice versa. So there's never really any reason to share my branch. And then so when I force push onto my own branch, and I can't accidentally force push onto the main branch, for instance, it's fine, because that's just my own work. I'm not overwriting anything. So I'm never scared to force push onto my own branch. If you do share your branch with other people, there is also the option, and a lot of people like to set an alias for this. Instead of git push -f for force, you can git push -- force with lease. And that means that it will force push for you, but before it does that, it will check if someone else has actually already made commits onto that branch, and it will still reject your force push. If that's the case, it'll say, wait, somebody else already pushed to this branch before you, so you have to rebase onto the origin first before I let you force push. So that's another way to kind of circumvent that. This is a very, very common way of doing this if you're using atomic commits. And I hope that addresses your concerns, but if not, feel free to ask me any questions. If there's enough time, I hope so. There is.
There is plenty of time. Anyway, should we just say thank you to Pauline? Thank you.
Thank you.
Yeah, we have about 10 minutes or so we can do some questions. Are there any questions from the room at all? Alternatively, you can drop it into the channel in Discord, if you're on Discord.
Really trying to look
One right at the very back.
Oh, there is.
Get my steps in. Whilst I'm walking down, I'm actually going to ask a question, which is, when you first start a project, there's that inevitable, you do a load of work and you've got this kind of initial commit.
Wait, can you speak up a little bit?
You've got this, there's inevitable that you do a whole load of work at the beginning of a project, and I always find it very difficult to get into the habit of atomic commits right at the beginning of a project, and you just get that kind of initial commit dump of everything. Is there a good way of sort of following the same steps there, or would you recommend
for
something
the
different?
Initial commit?
Yeah.
Like
when do you draw the line?
I usually, when I start something, I usually just start with a README, and then that's my initial commit. I don't think it's necessary. You're saying specifically if it's a giant commit?
I mean, yeah, it's something I see quite often. You'll get a large chunk of work goes in as an initial commit, as opposed to being atomic from the start.
Yeah, I think that giant initial commit usually tends to happen when someone has started working on it by themselves, and they're like, none of this nonsense when I started by myself needs to be in the history necessarily, so I'm just going to squash all of it and set it as the initial commit. I think there's nothing wrong with that. I think atomic commits become more important when you're working in a team, because it makes collaboration just a lot easier. So I think if you're just by yourself, there's not really that much need to do it. I still like to do it because I just like organizing my stuff. But yeah, I don't think there's necessarily anything wrong with that.
Okay, thank you. Right, back to our first question.
I feel like I look really silly just like peering out into the sun.
Hi. I had two questions, if that's okay.
Okay, yeah, no worries.
First of all, in terms of the peer reviewing process, you say you go through the tab and you review from the commits rather than the files.
Yeah.
It makes sense in theory, but I think unless you've done everything perfectly to the T, you'd end up wasting more time, because unless everything's perfectly in each own commit, you'd review things multiple times. I wondered if you had any personal experience with that. Does it happen a lot with your team?
Sorry, can you repeat that last bit? Because there's like quite a bit of echo. I don't know if everyone else has trouble
sure.
hearing.
So in your experience, when you reviewing people's through their commits, unless they've got everything perfectly into their own specific commits, do you end up having to review things multiple times?
Yeah. So this thing kind of really only works if your whole team is doing it. And then it definitely does save a lot of time and makes it a lot more organized. But yeah, if I have been in situations where not everyone on the team kind of agreed on it, and then it doesn't really make sense. There does need to be a team understanding that that is the strategy that we follow, and then it'll be a real time saver.
Okay, thank you. And for my second question, the way that we work is, I mean, in principle, everything you're saying makes sense, but then when we merge into the master branch to go to production, we do a squash commit.
Yeah.
Because then we'd feel that if there was a problem with that deployment, we can just revert that single commit. Mm-hmm. So at that point, all of this effort to split the commits out essentially feels wasted, maybe, because we've deployed to master. So the master's all squash commits.
Yeah. Yeah, that's actually a very common thing people do for various reasons. Like one of them is to be able to revert one single commit. Small side note: you can basically achieve all of that as well if you tag your releases, for instance. So you don't necessarily have to do a squash commit to be able to do all the things that you would if you do squash merge. That's one thing, but I don't think there's. I think that's a matter of preference. Personally, I also don't mind if it's squash merged, because I do think that the biggest advantage, most of the advantages that you get are going to be in the context of collaboration. So if you're still actively working on a branch and you have to rebase onto someone else's branch, it just becomes much easier if there's atomic commits. If everyone's using atomic commits, and also for clarity within the scope of a PR. One thing that I do think, I do have a slight preference for keeping the commits atomic even on the main branch, and that has to do with bisect. Because the more granular your commits are, the easier it'll be to find a really granular set of changes if you do a bisect. So that's I think the one reason, and I use bisect a lot. It's once you're used to it, it can be really, really handy. So that's my main reason for preferring no squash merges. But yeah, squash merges I think are also very valid.
That's great, thank you.
No worries, thank you.
Okay, any more questions from the floor? Yes,
Yeah,
down
they're
the other
making you
end.
run.
Yeah, this is turning into a workout.
They're making you travel.
Or are they plants? Have they planned this in advance, haven't they? Okay, so we've got 3. I'm going to go with the nearest first. Here you are.
I'll try to make the answers brief.
Hello. I don't know if there is an answer to this question, but I'm just interested in your thoughts. The ideal is to have every commit be a commit you could go back to, and that is a working state in the application. Sometimes you've got something into master, which you then find out has a bug,
Yep.
and you need to put another commit on top of it. Do you ever, where do you stand on the rewriting history versus the fact that there is a commit on master that is in a broken state? Yeah,
so I do think that when something is on your main branch and it's on production and stuff like that, again, I mentioned before that I don't see that there should be a reason to push to your main branch. I think once something is on your main branch, that is a public branch. It's been published basically, so you don't change that anymore. I also feel like the capturing every commit in a stable state is a nice goal, but I also don't think it's the be-all end-all of atomic commits. It's a nice goal because it has some advantages, but it's not always possible. And you're always going to have unexpected behavior. Short answer is don't rewrite your history on your main branch. Yeah, does it make sense? Okay,
Hi, yeah, so I very much work with the checkpoint style you described at the beginning. And my IDE makes it quite easy to work like that. So I don't use the command line very much. Mm-hmm. So do the usual suspect IDEs work well with this setup?
Well, I'm mostly PHP Storm. I think most of us are. I've really always worked with Git on the command line. That's just what I'm used to. So I'm not super well versed in how PHP Storm, for instance, does it. But I would imagine it's fairly similar in the sense that the merge conflicts that you do have, although from what I understand, it's quite easy to see the diff and kind of pick which side you prefer and resolve it in that way. The merge conflicts when you use atomic commits are just going to be vastly more simple, and that's the thing. So even if you're using your IDE and that makes it a little bit simpler, you're going to go from merge conflicts that span like 10 lines, for instance, to maybe sometimes having one small merge conflict here with a lot less like context that you need to be able to solve it. So that's more the advantage.
How far back in time do you go when you're kind of rebasing? So if you've been working on something for a week and at the end of this week you are making a change to a method in a controller that you built on the first day,
Yeah.
do you then squash those first and last commits together, or do you go back through the whole week's work and reorganize it, or where do you draw the line there?
Yeah, I do, and that, like, the way you phrase it does sound like it's cognitively a heavy kind of cognitive load. In practice, that's usually not the case, because in practice, what happens is you really know where everything kind of belongs. It's kind of hard to convey now, but yeah, it's usually pretty easy to classify. Oh, these changes just should go in this commit. And I also tend to not have very big PRs, so I'm a big proponent of having very short-lived branches with, not too many commits. But yeah, so I basically, until it's merged, I tend to organize my commits atomically.
Any more questions? Got another few minutes.
One more.
Yes.
You're also patient, thank you.
Yeah, so how we usually work is we try to also keep short PRs and make them short, but we won't rebase the stuff in a PR because then it makes it hard to track which comments have been addressed and reviewed.
Yeah.
But then we will just squash the PR and make that the atomic commit into the main branch and try to keep the main branch as atomic. What's your opinion on that instead of rebasing your PR, which will possibly lose information of who, if a comment has been reviewed, addressed or not?
Yeah, so that's another reason some people prefer squash merging and not really keeping it for code review purposes, right? Because if you're rewriting commits to address comments, then the reviewer might have to go through every commit again. I think GitHub has I think it's GitHub or GitLab, I can't remember which one, but it does have a view of there's been a forced push, but this was the previous version, so there are those that have a view like that. But also it's a really common strategy for teams who do use atomic commits, but still want to be able to see the changes after the PR was already open. They will make fix-up commits. So instead of making a regular commit, they will go git commit -- fix-up, and then add the ID of the commit that it kind of belongs to. So then in the PR, it will show up as a separate commit, so you will be able to kind of really easily see oh, this is the new ones after I already reviewed it, sort of thing. And then after it's been accepted, you can then really easily, through kind of the cleanup strategy that I showed, but a slightly different command, you can go into an interactive rebase and add the auto squash flag, which will then automatically take those fix-up commits and squash them into the commits that they belong to. So you can still organize it before you merge in that way and still be able to see the separate commits. Does that answer your question? Brilliant. Sweet.
I think we've got time for one more question.
If there's no other question, by
If
the
there's
way,
no more questions.
I would also like to show you this
there we
QR
go.
code with the cheat sheet so that you can go to the cheat sheet so you won't have any trouble remembering all the stuff that I showed you before. So hopefully that's helpful. I think that's, is that it? Or?
If that's your last slide, yes.
That is my
Thank
last
you.
slide.
Thank you, Pauline.
Thank you.